Okay, let's run through a few problems off the 11.3 worksheet. I decided to give you 4 problems at the beginning right here where they gave you the picture of a solid and just asked you to come up with the name for it right here. And I thought I'd make this one multiple choice, maybe make your life a little bit easier. So, surprise, here on number 1, the answer is C, because we have that little asterisk right there. But let's talk about why this thing is a pentagonal prism. The first reason for it, we want to try to take a look here at the last words, pyramid, prism, prism, and pyramid. So I'm hoping this is something we've gotten the hang of already. A pyramid is always going to be a figure that has some kind of base down here on the bottom, doesn't really matter how many sides, and then comes to one single point up at the top so that all of these line segments here are connecting to this one common point up on the top. That's the telltale sign of a pyramid. But in a prism, whatever goofy base that you have, let's see how much of that I can undo, whatever goofy base that you have there on the bottom, you are going to have, can I do this? Let's see, what if I copied that sucker and then pasted it right down here? Yeah, you're going to have a second congruent and parallel base on the opposite side of the figure, and then everything here is going to be connected with line segments, and that means that we've got rectangles on the sides of this figure. Now this is much more like what we're dealing with here in problem number 1. I see a pentagon down here on the bottom of this figure, 1, 2, 3, 4, 5 sides, and another congruent and parallel pentagon up on top on the opposite side of the figure. I see 2 bases, that's what that means. So that means this is a prism. So it's not A and it's not D. And prisms, if you take a look at the adjectives in front of them, prisms are named according to the shape of their bases. Well, as we just counted, 1, 2, 3, 4, 5 sides means that we are dealing with pentagons here, and that makes this a pentagonal prism. Hopefully you knock out 2, 3, and 4 and have no troubles there. All right, let's get back to some real computations right here. We're supposed to find the surface area of this figure, so the first thing we need to do is recognize what type of figure we are dealing with. And kind of like we just talked about a moment ago, we have got ourselves a base on the bottom that sure looks like a square. I'll come back to that in just a minute, but it's a polygon. That's the important thing. And then this one single point up here on the top that everything on the base is connected to. That is the definition, everybody, of a pyramid. And regardless of what kind of pyramid it is, the formula for the surface area of a pyramid is always exactly the same. Capital B, and just one of them, guys. In a prism, it was 2B because there's always 2 bases in every prism. But in a pyramid, there's only one, so we just have a 1 base right there. Plus, we have a 1/2, a capital P, which again means perimeter of the base, and then this new variable, which is a cursive L, which means something called slant height. And we'll talk about that in just a second. All right, so that's our formula for surface area of a pyramid. Let's see what we need. We don't yet know the area of our base. We don't yet know the perimeter of the base, nor do we know the slant height. So we've got a lot of work to do right here. But luckily for us, none of this is too bad. Capital B, area of the base. So now it's time to take a look at this base down here, which certainly was a rectangle because I see the 4 right angles, but we even got lucky on top of that. The 2 sides of that rectangle right next to each other that were given to us are the same. So technically, that base isn't just a rectangle, it's a square. So, regardless though, the formula for the area of a rectangle or a square is its base times its height. That 6 times 6 is going to get us 36 square feet for the area of that one base. Okay, let's move right along then. I'm going to go to red now. And we're going to talk about capital P, which again, try to say it properly. Capital P means perimeter of the base. So we're looking at the same shape we were looking at just a second ago, and now for perimeter, we're just going to add all the sides together. 6 plus 6 plus 6 plus 6, that's 6 times 4. 24 then is going to be the perimeter of that base. And then I'll go green now for the slant height, this piece right over here, although I really should have done that in red. So the definition of a slant height is a measurement that goes from the top of a pyramid here, straight down the middle of one of the sides here, and it looks something like that. Two important things happen here. The slant height is perpendicular to that one side, and it also bisects this piece down here on the bottom that it's drawn to. Well, sure enough, right here, guys, that 11.4 foot segment that they gave us as a dotted red line there, that's our slant height. And I think in most of the problems on this worksheet, the slant height was given to you. So the 11.4 is going to go right there in the place of the cursive L. And now that we know all that, everybody, that is all the information that we needed. We're ready now to go to the calculator and type all this in. So, wrong one. So let's see what we've got here. All right, we had let's clear all that out. We had a 36 for the area of our base plus a 0.5 times the perimeter of our base, which was 24, times our slant height, which I believe was 11.4, gets us an answer of 172.8. Nope, wrong one again. 172.8. Come on, Mr. Fontana, get it right. 172.8, there we go. And since linear units, were all given to us in feet, surface area is going to be measured in square feet. So 172.8 square feet is our surface area here for that square pyramid. Okay, let's move on to number 9 and try something a little bit different. Once again, looks like we have a polygon down here on the bottom, like that, and then it all comes to one point up here on the top. So just like number 5, it looks like we're dealing with a pyramid here. So that's all we need to worry about for now. Surface area of a pyramid is capital B, just one base, plus 1/2 times the perimeter of your base multiplied by the cursive L, which is your slant height. So let's get ourselves ready here. I don't think we know any of these three things just yet, so I'm going to leave them all blank. Capital B plus 1/2 times capital P times a cursive L. And I think the hardest thing here, without question, is to come up with capital B here. Now, in the last problem, that base was a square, and it was really easy to come up with the area of your square. But for us in this case, our base, we said had 1, 2, 3, 4, 5 sides. Our area is a pentagon. And like we said in the last video, the only pentagon we really know how to take the area of is a regular pentagon. But lucky for us, we've got tick marks, guys. Here, here, ooh, hard to see, here, here, and here. That means that all 5 sides of that pentagonal base are congruent, and that makes this a regular polygon. So to find capital B, that's the same now as the area of a regular polygon, which is 1/2 times its perimeter times its apothem. So let's see what we can do here. That's 1/2 times, well, as far as perimeter goes, we can see, before I wrote over it, that each side of that pentagonal base is 9 miles right there, and there's 5 of them. They're all congruent to each other. So I would go ahead and multiply to get my perimeter here, 5 times 9, and get 45 for the perimeter of that. And the apothem, lucky for us, is this piece that they gave us right there. 6.2 miles is the length of your apothem. So now let's put that in the calculator. 1/2 times 45 times 6.2. And that is going to get us tell us that the area of that pentagon is 139.5. All right, so we'll write that down here. And then again, that was capital B. So the 139.5 is going to go right there. Let me switch up my colors a little bit. I'll do green first here. All right, so capital P, the perimeter of the base. Well, we got the same information here just a second ago. That base has 5 congruent sides. Each one of them is 9 miles. So the 5 times 9 is again going to get us 45 for the perimeter of that base. And the last thing we have to figure out, again, can be very difficult in some cases, the slant height, but in this problem, I think they gave it right to us, guys. This piece coming right down here, that is the slant height, 13.5 miles. I love the units they use right here. I don't know what pentagonal pyramid they're talking about that's this many miles tall, but okay, guys. Anyway, at this point, we have filled in everything we needed to know in step 2. So now for step 3, we'll type all of that into our calculator at once. So we start off with our area of our base, which is 139.5, and we're going to add to that 0.5 times the perimeter of our base, which was 45, times our slant height, which was given to us as 13.5. And that should get us our overall surface area now of 443 and a quarter. So 443.25. Since all of our linear units were given to us in miles, surface area is going to be measured in square miles. So 443.25 square miles is our answer for number 9. And the last one I wanted to do with you, number 13. Now we're shifting gears into cones, everybody. So step number 1. And by the way, if we needed help with this, the reason we would identify this as a cone, we have only one base. It's over here on the right-hand side of the figure, and it has a point on the other side. So it's just like a pyramid in that regard. The only difference is a pyramid always has to have a base that's a polygon. Here in number 2, our base was a square. In number 3, that base was a pentagon. Well, if your base is a circle, it's not a pyramid anymore, but it's now a cone. And the formula for surface area of a cone is going to be pi r squared plus pi r L, L again being the slant height. And just like I did before, let me explain real quickly. The formula that we've been using for the last 2 problems, surface area of a pyramid, was capital B plus, that was a 1/2, a capital P, and then an L. This formula that we just came up with right here is really the exact same formula. Here's the reason why. Capital B means area of the base in a pyramid. Well, in a cone, that base is always a circle, and the area of a circle is simply going to be pi times your radius squared, plus 1/2 times capital P means perimeter of that base. But there's really no such thing as perimeter of a circle. We use the word circumference instead. And the formula for circumference is 2 times pi times the radius. L, the slant height, stays exactly the same. And the only thing that happens right here is the convenience that we're multiplying 1/2 times 2. Well, half of 2 is 1, and with a factor of 1, we can basically just ignore that. So that leaves us with a pi r squared plus pi r L, and that's where this formula right here in step 1 comes from for surface area of a cone. Okay, step 2, let's fill in what we know. Surface area is going to be pi times, I better erase all the junk that I did on top of that. Okay, the radius of that cone is given to us right here, guys. Our radius is 11, and we'll square that, plus pi times the same radius now of 11, and cursive L, the slant height, that's this piece right over here, which they've given us as 24.6. Okay, now again, if you look at the directions, just like we did on number 13 on the 11.2 worksheet, the directions tell us to leave your answers in terms of pi. So what that means for us right now, everybody, is that I am going to go to my calculator, but I'm going to leave the pi out of it. So what do we have here, everybody? We've got 11 squared, and then we're going to go plus, the radius was 11, and the slant height there was 24.6. Okay, so when I do that, that gets me 391.6. So I'm going to write that down here, 391.6, but because we left the pi out of our calculations, the pi just tags along at the end right here. Linear units were inches, so surface area units are going to be square inches. Okay, so 391.6 pi square inches. All right, everybody, let's give the rest of 11.3 a try. Let me know if you guys have any questions, and good luck.